Welcome everyone to episode 48 of our Space Shooter DevVenture. So in our last session we were trying to get the patterns to be multi-behavior rather than mono-behavior, and we got it right. And then I remember at the end of our session I was supposed to do some cleanup, right? I was supposed to remove some of that legacy code, and I've done that in between the last live stream and now, both to save time and to also just make progress outside of these DevVenture live streams, right? So excuse me. So now I'm going to carry on where I left off, and that is here at the bottom. So at the end I asked what was I still supposed to do now that all that work is done, right? I asked, okay, well, what's left to do before we move on to the testing phase of our new pattern-based 3-layered AI system, right? What is left to do that we haven't finished yet, right? So what's left half finished that needs to be finished, and then we can carry on with new things like testing and debugging and making sure that all this works. So I asked Perplexity, and here's what we got. We found out that right before you refactored the pattern system, you were working on finishing the enemy shoot behavior so that it activates correctly via the tactical layer with proper parameters like target, continuous flag, and so on. It checks the line of sight, the range, and target validity, and then fires through the gun system. It emits behavior completed with completed or failed and a reason when appropriate. Designing and wiring multi-behavior patterns so an attack pattern runs with shoot, seek, shoot, and flee as a chain sequence managed by type NPC behavior manager instead of only mono behavior patterns, right? And then loose ends that were pending and are now essentially addressed are to decide how to carry the pattern sequence, and you chose patterns in the enemy ship controller plus behavior sequence in the parameters dictionary, and that's how it's been implemented, right? And then also to extend the NPC behavior manager to stop current sequence and have a sequence index, and then start the first behavior and advance on behavior completed and clean up on failure or cancel. At this point, for step 1, shooting and pattern chaining, there is nothing obvious left half done in the code you've shown. The next logical move is exactly what you suggested. Start testing the attack pattern in a scene with enemy ship, like with an enemy ship with behavior seek and behavior shoot plus the NPC behavior manager, and watch the logs, and then we can fix any runtime issues that appear. All right, so now what we can do is we can actually take this, excuse me, no, that's right, we can take this into the testing seek behavior scene in Godot engine over here, testing seek behavior in the 3D scene. So now we have an enemy ship, right? And we have all our waypoints, and now we've got the triple layered AI architecture system, right? So we've got enemy ship controller, NPC behavior manager, and the operational layers, right? So behavior seek, behavior shoot. We can actually see how these patterns are flowing, if at all, and test it. So let's go ahead and do that, right? Just want to double check before I do that in the globals we have an enemy ship controller. That's correct. Okay, and it's enabled. Then for enemy ship, I check the nodes, the groups. Enemy ship is type enemy ship, which is right. Waypoint is type waypoint. and within the waypoint node there should be a target which is of type target. So yeah, okay, and then that seems like everything. All we need to do now, of course, is enable that test attack pattern code, right? Because remember we have this in the script of enemy ship controller, we have this test attack pattern function, right? And so what that does is currently nothing, right? I mean, it does, obviously it does work, or it does expect something to work, right? It expects that all of this should just work, that it should, but it needs to be called. That's the point I'm trying to make. I'm not sure why I'm not able to to speak very well this live stream. Anyway, I need to have something to trigger this test attack pattern. That's the thing I'm trying to explain, right? Now let me go into the process function down here. No, not process, input. Here we go. Input is action pressed UI accept. Okay, so when the UI accept key is pressed, I think, excuse me, UI accept I think is spacebar. Let me just double check that. Project settings, input map. Do you see it? Yeah. Oh, okay. So enter or spacebar. Okay. Or keypad enter. By the way, keypad enter is the one on the numpad, and enter is just enter, in case you were wondering. So if I press any of these three keys, it's going to do the basic attack, test shoot behavior, right? So what I can do now is I can hijack that same input to do the test attack behavior instead. So I can comment this out and replace it with test attack pattern instead. So now when I press the spacebar, it's going to test the attack pattern rather than immediately do the primitive continuous firing and orient yourself towards the waypoint, right? And yeah, so it should seek an attack, but it can't flee yet. We need to build in flee. So that's the next step after this, right? Once we've proven that test attack pattern works, that it seeks and attacks, then we can move on to adding flee, and then it will be able to seek, shoot, and flee, right? So seek the target, fire at the target, and then flee from the target, and then turn around and then go back and seek and shoot and repeat. Do this like swarming, well, not swarming, but like swooping. That's the word I was looking for. This kind of like swooping behavior that you see in some birds, right? Or in some insects too, like dragonflies, right? If you notice dragonflies, when they attack those large flocks of smaller flying insects, they tend to swoop and like do all kinds of maneuvers in the air, right? And we want to see that kind of behavior with the attack pattern. It should seek, shoot, and flee, and seek and shoot and flee, and continue to do this repeatedly until the target is destroyed, right? So let's have a look. Enough talking. It's not doing anything, of course, because I haven't pressed anything yet. So I'm going to press it now. So 3, 2, 1, go. Okay, nothing's happening. 3, 2, 1, go. Okay, so clearly this isn't working, but we have logs, right? So let's have a look through the logs. Okay, over here we can see the waypoints were set up, or they were found and being set up, and then configuration successful for all of these waypoints, then level initialized, assigning attack pattern to ship 0. Okay. Pattern assigned attack, starting behavior seek, index 0 for pattern attack. Behavior complete, seek with status failed. Aha! So it failed to seek. So we have our first failing point. Perfect. Right? And then behavior failed, seek, the reason, no target specified. Of course, no target specified. We didn't see any target specified in the script. Down here, this attack pattern. Okay. So yeah, it obviously it wouldn't have worked, right? As you can see here, there is no way in this script that we are finding a waypoint. We're not even specifying find a random waypoint. And when we put it into parameters, you can see any other shared parameters like target node, position, etc. None of that is specified, right? And we're literally just assigning the pattern. We're emitting the signal pattern assigned, enemy ship ID, what is the pattern, and any parameters. And so clearly it's not going to do anything, right? Here you can see no target specified, the seek behavior completed, target was reached. It wasn't, but there was no target, so it was reached anyway, right? Then behavior complete, seek with status completed. It shouldn't be saying this though. Anyway, pattern empty, complete sequence, assigning attack pattern to ship 0, and then it just repeated the same thing. And this is when we press the menu, then this thing comes up, right? So I'm going to copy this, and I'm going to put it in Perplexity, and I'm going to tell it that it's failed. And I'm not surprised it failed, because the code, of course, isn't working. So let's copy this, take it to Perplexity, make sure we're in the right place. Yes, okay. Here is the output log from testing the attack pattern. Yeah, testing the attack pattern using test attack pattern using the test attack pattern function. Oh no. Copy the whole thing. There we go. That's better. And here is the enemy ship controller.gd file. And then we just copy everything here. paste it there, and I can say as you can see, the seek behavior failed, and there's no wonder, or rather, and that's not surprising. Based on the test attack pattern functions logic. It's not using any preset waypoint node, nor is it finding a random waypoint node. It simply expects the enemy ship to seek an unspecified waypoint node, which fails. Let's address this problem now. You write about the cause. The attack pattern is being assigned with no target information. So seek has nothing to move towards and correctly reports no target specified. Let's fix it by giving the pattern a valid target in the parameters, and then you can retest it, right? So what's happening? The attack pattern builds pattern name attack, behavior sequence, seek, shoot, flee, parameters, pattern name attack, and then behavior sequence, behavior seek.activate expects either parameters target position or parameters target node path. Since neither is present, it emits failed with reason no target specified, which matches your log. So seek fails immediately. Excuse me. Seek fails immediately, and then due to how things are wired, a later frame still triggers its completed path, giving you the odd double log. Simple fix. Pass a waypoint as the target for the attack test. For a first test, just aim at a specific waypoint like the first one, and then update test attack pattern like this. So there's quite a bit of code here. If you want me to go through it, I can, but what I'd rather do is I will write the code over into GDScript in the editor and keep this off screen and just use this for referral, because as you can see, it doesn't do a very good job sometimes, especially when it's trying to separate the original if statement from the rest of the code body. For whatever reason, it doesn't include that in the code block, and that is perplexing, but then it is perplexity, so anyway, off to one side with you and into the code editor with me. Function test attack pattern. If not enemy ships or enemy ships.size is 0, then return. Okay, then before we do the variable ship ID and pattern name, we need to add a new if statement. So we will say if waypoints dot is empty, then we push the error enemy ship controller no waypoints for attack pattern test, and we call return. Okay, so if there are no waypoints in the waypoints array, then of course there's nothing for us to seek. Attack pattern won't work and it'll fail. For now anyway, right? Because remember, we aren't always going to be seeking waypoints unless we make all ships, all vessels, a waypoint as well. That's an interesting thought. To make, you know, mining vessels and defender vessels and pirate vessels, all of them, including the player, to make them all waypoints, just moving waypoints rather than static ones. That's an interesting thought, but for now, let's just not add additional complexity and just focus on what we already have, get that working. And once it works, we can think about expanding that into more advanced implementations. Remember, I mentioned a few live streams quite a long time ago now, the so-called Shreknik, you know, to build a system up by layers, you know, using the so-called onion. You know, you build an onion layer by layer, and each layer is a complete and stable iteration that you then build another layer on top of. And so, yeah, for now, we'll just keep everything as is, make sure it works, then think about expanding or scaling or advancing or adding more complexity or whatever, right? Right, so we've got the additional check that if the waypoint is empty, we push an error and return. Then we have these two variables, that's still the same. If patterns has a pattern name, then behavior sequence, type array, patterns, pattern name, dot duplicate. Aha, here we go. This is the next line. So we have a variable here called target waypoint, and that is of type waypoint, node 3D. We assign that to be on waypoints in position 0, the first waypoint. Why not? Then we have the parameters dictionary, which we're going to have to add things to. We've got the pattern name, the behavior sequence. Now we need to add in over here we have to add in target position, and then the target position is target waypoint dot global position. Okay, and then the next one, the next one is the target node. And that would be target waypoint. Okay, so we've added additional information, target node or position. We can take out that now, additional parameters, because we've already added those in, right? So if I go into the test environment now, and now if I test attack pattern, hopefully it'll go towards waypoint 0, but that remains to be seen. So waypoint 0 is the first one, that's waypoint 1 over there. If I press enter, it will seek. And it will shoot. And it will continue to shoot and shoot and shoot. And as you can see, the bullets are spawning outside of the collision space for the waypoint because it's obviously too far away, right? Now, that's an interesting side effect, but as you can see, it's working, right? It seeks the waypoint and shoots at it. So now we can quit. And obviously, as you can see, it's got hundreds and hundreds and hundreds of thousands of plasma bolts in our script. and it doesn't make sense to copy all of that and paste it into Perplexity, so I'm not going to, right? All I'm going to do is describe the behavior, and if it wants the log, then I'll give it the log until the point where it starts shooting thousands of projectiles or rather hundreds, and then by extension thousands of debug prints. If even one projectile causes 10 debug logs, it only takes 100 projectiles before you have 1,000 debug logs. So yeah. Anyway, if I go into Perplexity, before I do though, let me just go to Seek and behavior seek, right? And as you can see here, distance to target, target position, parameters is active. So down here, we've got this new variable called distance to target, direction to target, and distance to target. Okay, so if the distance to target is less than threshold, so we need to add a variable called threshold, right? And so going into this, I knew it would be difficult and really complex. But as you can imagine, it is even more difficult and complex than I originally thought. I'm just trying to think about this. See, this is why I want to do it outside of the live stream, because thinking about this isn't pleasant for me to do on camera, and it's not really exciting for you to watch, right? But it is realistic for you to see, right? As a person who's watching me do game development and wants to see what game development is like, well, this is what it's like. You know, you hit this thing that you hadn't considered, this problem that you haven't considered before, and now you're stuck having to solve it from scratch. I mean, we could look up examples where people have solved similar problems, but in some cases you are the first person to solve a problem like this ever, right? I mean, I'm definitely not, but sometimes it's true, right? You go into such a niche in your game that nobody's done this before, and the best you can do is look at similar things that other people have done, which are, you know, slightly similar to what you've done, and then try and figure out what you could do from what they've done, right? How did they solve their problem? Could I expand this or extrapolate from this or adapt this to a solution for myself? And the answer is usually no. Not so simply. Not that simply. So I know I'm probably rambling a little bit now, but I'm just giving my brain a chance to think while I speak. So it's not for nothing. It's definitely not for nothing. It's just so that I have some time to think about the problem. Right. So we need to add in some kind of threshold. And by doing that, we can check if the enemy has reached firing range. You know, the range within the, before they can start shooting at their target. I should probably spread the waypoints out a bit more so that the distance traveled by the enemy ship is further, and it gives the enemy ship more time to fire at the target before it needs to flee, right? But before I do that, right, now we've got the attack. We've got the testing for the attack. And we know that testing the attack pattern works to the point where it will seek the target and start shooting at the target once seek is done, right? We know that works now. And so we don't need to worry about that anymore. All we need to worry about now is having correct pattern chaining, or rather behavior chaining within a pattern. And we also need to worry about, maybe not worry, but we need to think about excuse me, I thought I heard something and I needed to check. It's nothing, don't worry. Just trying to remember where I was before I got distracted by that. Yes, I remember now. We need to implement flee, right? We need to implement behavior underscore flee so that we have the full pattern, right? And then we can start working on doing excuse me, it seems that I'm yawning again. And as you can tell, it's because the room is stuffy. I don't know if you can tell actually, but the doors are closed. I didn't open them this time. And it's a good thing I didn't, because today is quite noisy outside. You know, cars and lawnmowers and all kinds of noise pollution. But that's not your concern, that's mine, right? So I need to do the flee behavior. Okay, so let's go ahead and do that. I'm going to open up the Envato guide for the flee behavior. Here it is. Understand steering behaviors. And if we go towards flee and arrival, let's just go through this. I think it's worthwhile that I go through this with you guys, so that I can refresh my memory on this, but also so that you can benefit from the tutorial as well, right? As you can see, it's not my content. It is from code.tutsplus.com. It's a series on Envato Tuts Plus, and it's this one here, Understanding Steering Behaviors, Flee and Arrival by Fernando. My apologies, I can't pronounce that surname. I won't be able to do it justice, but it's over here, right? So from Fernando. So let's learn from Fernando what it takes to have a flee behavior. So flee behaviors, steering behaviors aim to help autonomous characters move in a realistic manner by using simple forces that combine to produce lifelike improvisational navigation. In this tutorial, I'll cover the flee behavior, which makes the character move away from the pursuer, and the arrival behavior, which makes the character slow down and stop as it approaches the target. That's useful, because now once we reach firing range, we can start doing more advanced analysis, right? We can do checks like relative velocity, you know, checking if the target we are approaching is moving. If it's not moving and we are moving, we want to maximize the shooting time, and so we slow down and we start firing at a slower pace towards the target so that we don't smack into the target as we're shooting, right? We can get more projectiles in before we have to start fleeing again, right? And then if the target is moving, we can start managing or moderating our speed so that when we are chasing after a mining vessel, for example, the mining vessel is a bit slower than the pirate vessel. If the pirate vessel is chasing a mining vessel, it will then have to slow down to match the speed of the mining vessel and then just bombard with fire and never have to flee. Just keep moving, keep the same distance, and just follow and keep pelting with projectiles. You don't have to do swooping behaviors if you don't need to, right? The best solution is usually the simplest one. If we assume that the pirate vessel can't stop, that the pirate vessel cannot stop in space, it has to keep moving, then we do the swooping. We do the slowing down, we do the swooping, we do slow down, shoot, accelerate away, and then come back, and then slow down, shoot, accelerate away, and then come back, right? That's the swooping. But if it can stop, then that's more efficient, right? Just move close to the target so you don't lose accuracy, stop completely, and then fire away until the target's gone, and then just move on, right? And yes, that seems simple, and then maybe a little bit boring, but what do you expect? You know, like if you're thinking about like a realistic scenario, as a pirate vessel pilot, wouldn't you prefer to just stop and shoot at your stationary target? Do you really want to keep flying the whole time and increase the risk of inaccuracy, imprecision, and just wastefulness, you know? Like wasting fuel, wasting projectiles, wasting time, wasting all of this. When you could have done a better job just stopping and shooting and then carrying on again, right? I get it that in some cases it makes sense to keep moving, especially when there's enemy defenders around trying to actively destroy you. So we'll need to take that into account as well, right? So there are multiple factors we'll have to consider. But again, like I said, we build on it layer by layer by layer by layer, right? And I know that seems repetitive and monotonous maybe, or perhaps it seems what's the word I'm looking for? Tedious. That's the one. Tedious. Maybe it seems tedious to you, but again, this is what game programming is like. So it's not necessarily all of game development, right? Not all game development is like this, but a lot of the programming side of game development is like this, you know, especially if you're dealing with systems like I am. We're writing an entire system on controlling the AI. And so everything has to be super advanced, you know, to have even basic functionality. The interconnectedness of the behaviors and the patterns and the tactics and the strategy and the operations, everything working together becomes so complex, so fast, that the only real way for a mere human like me to cope with all of it is to build on it, as I mentioned, in this like Shreknik of building layer on top of layer, stable and stable and stable, right? So yeah, slow down and even stop as it approaches the target. Okay, so carrying on. Setting behaviors aim to help autonomous characters move in a realistic manner by using simple forces that combine to produce lifelike improvisational. Oh, we read that already. This is, I suppose this is the abstract, and he's just repeating this here. Note, although this tutorial is written using AS3 and Flash, you should be able to use the same techniques and concepts in almost any game development environment, because it's mostly using vectors. You must have a basic understanding of mathematics and vectors, right? So running away. The seek behavior described previously is based on two forces that push the character towards the target, right? The desired velocity and steering. So the desired velocity is one force and steering is the other force, right? And here's how we can calculate those. The desired velocity is the velocity to the target, and steering velocity is the velocity we need to influence our current velocity to change its course to match that of desired velocity, right? So while he mentioned that there are two forces, there's actually three, because you've got your existing force, which is the, well, not force, but a vector, right? Your current velocity vector, and then you need an additional vector called steering to push the current velocity vector to be collinear with your desired velocity. So you've got your two, we can call them driving vectors, right? And then you've got your resultant vector, or your current velocity, which is your resultant vector, right? Every frame, the current velocity is the resultant vector of the previous frame, you know? So the desired velocity, in this case, is the shortest path between the character and the target. It is calculated by subtracting the target's position from the character's position. The result is a force vector that goes from the character towards the target. As you can see here, that's what I was kind of showing you. And then the seek behavior from the last tutorial, which I never actually covered in any of my live streams. I managed to do that before starting live streams. So the seek behavior, the flee behavior uses the same two forces, but they are adjusted to make the character, in quotes, run away from the target instead of run towards the target, right? And instead of having seek steering, we now have flee steering, which is the opposite. So you've got your desired velocity, and you have your current velocity, and you want to go away from the target, and so you've got you've got a flee steering vector to push you towards the desired velocity, right? Now, in our flee steering, in our behavior flee script, we're going to need to have a function that we can call to calculate what the desired velocity is, because it's not obvious, right? We could make it that it just turns to face 180 degrees away, the furthest possible angle away from the target. So do a 180 and fly away. Or it could just be adjust your course so you don't collide with the target and then move away, right? In any direction. Choose a random direction and fly away. And you know, we could even have a so-called least resistance factor in the angle selection process that makes sure that the enemy pirate ship doesn't do something like a 180. Because in reality, if you were a pirate piloting your vessel, you wouldn't want to do a full 180 anyway. You just want to do something like this. You come in towards the target. If the microphone is the target, you come in, you shoot a little bit, and then you just adjust your trajectory and move up like this and go off in this direction. And then later on, you come back, you shoot, and then you steer up and go away again, right? Or you do something like this. You shoot and you just fly past. And then you come back from on top and you shoot and you fly past, you know? Something like that. So it doesn't have to be a full 180, right? Because again, you want to have this like swooping, you know? Almost like a... Well, we'll just call it swooping. Okay, so the flee behavior. That new so-called desired velocity vector is calculated by subtracting the character's position from the target's position, which produces a vector that goes from the target towards the character. And then, of course, you have to slide that vector away onto the character, right? So this vector here was basically just taken and shifted along to start from the player or the entity and move out from there, right? So the same magnitude and direction, but just shift the origin of the vector to be the origin of the actor. Because remember, I told you the real term from years ago in game development was agent, right? The AI agent in your game. But now, because there are already these new AI platforms and things that have agents, and you can create your own AI agents and stuff, now we can't use that term AI agent anymore. And so I changed it in my live streams to be AI actor instead, right? And so now the AI actor has this desired velocity, right? The resulting forces are calculated almost the same way as in the seek behavior, right? So desired velocity is the normalized difference between position and target, and that normalized vector multiplied by your maximum velocity. So this gets you your direction, and this gets you your magnitude, okay? And then your steering is the desired velocity minus velocity. And I'm not sure what velocity is supposed to be. Was it defined anyway up here? It wasn't. So velocity is this mystery variable that we have no idea what it is or what it means. Anyway, the desired velocity in that case represents the easiest escaping route the character can use to run away from the target. The steering force makes the character abandon its current route, pushing it towards the direction of the desired velocity vector. Comparing the desired velocity vector of the flee behavior with the desired velocity vector of the seek behavior, the following relation can be established. The flee desired velocity is literally just the negative of the seek. It's literally just get your seek velocity times it by -1. And adding escape forces. So this is what we actually want to see. We don't want it to go like this and then flick around and fly in the opposite direction. We actually want it to do some kind of arc or swoop, right? So after the steering force is calculated, it must be added to the character's velocity vector. Since that force is pushing the character away from the target, every frame the character will stop moving towards the target and start moving away from it, producing a so-called flee path, the orange curve in the figure below, right? And then the addition of those forces in the final velocity or position calculation are handled in the same way as before. And before just takes you to behavior seek, as you can see at the bottom there, over here, right? So below is a demo showing several characters forming the flee behavior. And of course, it's not there anymore, because modern browsers just don't support the embedded code that he is trying to show. Remember that this is a very old tutorial, but the algorithm and the logic is still sound. So there's no loss. Well, I mean, there is a loss, but no real loss. We haven't actually suffered too much. We just don't have a live demonstration, that's all, right? So move the mouse to move the target. We don't have that. Every character is placed at the center of the moving area with a random velocity, and they will try to flee from the target, which is the mouse cursor in the example that is no longer present. The addition of all forces makes each character smoothly abandon its current route and flee the target. Currently, the target affects every character. Ignoring the distance from them. Currently, the target affects every character, ignoring the distance from them. it could have been limited to an effect area where the character would flee only if it is close enough to the target. And then arrival, similar to flee and seek, but of course it's different, so it needs its own distinction, right? The seek behavior, as we've seen, makes a character move towards a target, and when it reaches the destination, the steering force keeps acting on it based on the same rules, making the character so-called bounce back and forth around the target, right? The seek behavior, oh no, it's talking about the demonstration that isn't present anymore. The arrival behavior presents the character from, or rather it prevents the character from moving through the target. It makes the character slow down as it approaches the destination, eventually stopping at the target. The behavior is composed of two phases. The first phase is when the character is far away from the target, and it works exactly the same way as the seek behavior does. Move at full speed towards the target. Then the second phase is when the character is close to the target, or inside the so-called slowing area, a circle centered at the target's position. So in our case, that would be a sphere, some spherical radius from the target. Once it reaches that, it needs to start slowing down, right? It needs to start slowing down and start shooting, and then we can have an even smaller radius inside that, after which it needs to start fleeing, right? So it could do seek, arrive, shoot, flee. Or maybe seek could become arrive as a singular behavior. It's fine. We can integrate. Why don't we integrate arrival into seek directly, specifically, right? And then once it reaches the slowing area, it needs to trigger fire. And then once it's triggered fire, it starts shooting, of course, and it keeps on arriving, in quotes, arriving towards the target until it reaches the so-called fleeing zone, and then it needs to do a flee, right? Yeah, let's do that. When the character enters the circle, it slows down until it stops at the target. Of course, for us, that isn't the way we want it to be. We just want it to seek until it reaches the slowing area and then start shooting until it reaches the fleeing area and then flee, right? And then repeat and repeat and repeat until the target is destroyed, or until the pirate itself is destroyed, and then slowing down, right? So when the character enters the slowing area, its velocity is ramped down linearly to 0. This is achieved by adding a new steering force, the arrival force, to the character's velocity vector. The result of this addition will eventually become 0, meaning that nothing will be added to the character's position every frame, so there will be no movement. And so if we look at the code here, we've got velocity is truncate, the velocity plus steering, and max speed, right? So basically what this function is trying to do is say, get the result of this addition, add steering to velocity, and if it exceeds max speed, then just truncate it to max speed, right? And then position is the addition of velocity on top of position. So remember, position is a vector, velocity is also a vector. You can do vector addition on the two of them, and yeah, so you do that every frame, right? And then truncate is literally just this is literally just the definition of the function they're calling here, truncate, right? Taking in the vector 3D and a maximum number. And here's the logic. So variable I is of type number, and I is max divided by vector.length. Remember that max is a number. So the maximum speed divided by the vector's length, or the magnitude of the vector, and then we say I is the same as I over, or I, or okay, so this is a ternary. This is a ternary operation. So I is equal to I if it's less than 1. Otherwise, actually, no, I don't fully understand this term, this ternary operator. I'm not familiar with this particular type of syntax to the level where I can say, oh, that's exactly what it means. It doesn't matter, right? Truncate is literally just, it's defined here. Anyway. In order to ensure the character will gradually slow down before it stops, the velocity should not become 0 immediately. The gradual slowdown process is calculated based on the radius of the slowing area and the distance between the character and the target. And then this is just the algorithm to do that. I just want to see how much more is left. Quite a lot. So we have come to the end of our hour. Unfortunately, I can't get to the end of this tutorial in our session. If I had thought of it at the beginning, I would have gotten through all of it now. But yeah, I think for these live streams, it makes more sense for me to talk about things and then actually focus on implementation in between the live streams. And if you disagree with me, then go ahead and disagree with me, but do it in the chat so I can see. Right? Don't silently disagree with me behind the scenes somewhere behind your screen and I have no idea and I just carry on oblivious to your disagreement, right? Please do engage with me and the community on YouTube and Discord, right? The descriptions have the links for my coffee page and for Discord, and you can get to me either directly in the chats here or on Discord. Join the community, right? And then go visit the coffee page, right? If you want to support the channel, go visit the coffee page. It's there. Speaking of the coffee page, thank you so much to Cubes, our junior DevVenturer. Your support is really appreciated a lot. And to the rest of you all, thank you so much for your time and attention.